So we have to talk about an important topic in tensor analysis, that is our quotient law. In tensor analysis, it is essential to know whether the given quantity is a tensor or not. If the given quantity is a tensor, it should obey the transformation equation. If the given quantity is not obeying the transformation equation, it is not a tensor. Quotient law states that if quantity A is multiplied by an arbitrary tensor and the result is a tensor, then the quantity A is also a tensor. Say A, I, J, K is a given quantity. Multiply this by a known quantity B, J, K, L. Then we can get this J and K cancelled out. C, I, L, a new quantity. Suppose this is a tensor, then the taken quantity is also a tensor, because this is a known tensor. If you multiply unknown quantity with known tensor, if the result is a tensor, then the assumed quantity, the taken quantity, is also a tensor. That is our quotient rule. Now we have to verify this. Let A be a given entity to be tested whether it is a tensor or not. Consider an arbitrary tensor Bjk. Just we have taken an arbitrary tensor. Say this is an arbitrary tensor. This is a tensor. This is unknown. Do not know whether it is a tensor or not. So that multiply these two, we can get the quantity C. Say J and K are removed out. C, I, L. I is in covariant form, L in the contravariant form. To prove this, if A is a tensor, then we have to prove A bar mu sigma B bar mu sigma rho equal to C bar mu rho. Here I is transformed to a new coordinate mu, J is transformed to a new coordinate mu, K in sigma, L in rho. These are all the coordinates we have assumed. See here, instead of I, mu, instead of J, mu, instead of K, we have used sigma. Then instead of this L, we should use rho. We are in the position to transform these coordinates. This is transformed form. A bar of mu sigma, then B bar of rho mu sigma equal to C bar of rho mu. Now we have to write the transformation equations for these two. We have to write the transformation equation for this and this. After getting the transformation equations, we have to substitute the same in equation 1. Now see here, the transformation equation for the quantity B, J, K, L, where L is in contravariant form, J and K are in covariant form. Then for this L, the coordinate is rho. So B bar rho, for the coordinate J nu, for K sigma. Mu sigma equal to dou x bar, write on the coordinate of L, that is rho, divided by dou x, or dou x superscript L into these two are in covariant form. Dou x superscript j, dou x bar nu, dou x superscript k, dou x bar sigma into this term. This is mere transformation. The same manner, write down the transformation for CIL. I is in covariant form, L is in contravariant form. This is a transformation equation. Using these coordinates, you have to transform. Now substitute these two values in equation 1. You can get the new form. If you substitute, we can get the equation of this type 2. From equation 1, CIL is A into BLJK. This is our assumption. Now substitute this value in equation 2. Instead of this quantity, we have to substitute this. This is our equation 1. Now the equation 2 takes a new form. See, this is the form of 2. Then take this dou x rho bar divided by dou x bar L outside. Write down the rest of the quantity. Here also the term is present. Bring this term to the left hand side. So minus of the remaining quantities. Entire is multiplied by this BJKL. Just take out this term outside. Bring this term to the left hand side. Then take out this term outside. And align the rest of the terms by taking this term commonly outside. This is equal to 0. Now multiply the above equation by dou x superscript m divided by dou x bar rho. See here, dou x bar rho is present here. Now we have to multiply this equation by dou x superscript m divided by dou x bar rho. See, this is a multiplication. Dou x superscript m divided by dou x bar rho into this dou x bar rho divided by dou x superscript L. This is equal to 0. Now, see here, delta ml, which is equal to dxm divided by dxl. This is dou xm divided by dou x bar rho into dou x bar rho dou x or L. These two can get cancelled. Then once again we can get dou x m divided by dou xl. This is our Kronecker delta. Therefore, we may replace them by means of del Lm, Kronecker delta. Because Kronecker delta is variation in x in terms of m, variation in x in terms of L. This is equal to this much. Therefore, instead of this, we can put del Lm. Because these two get cancelled, we can get dx over m divided by dx superscript L. That is delta Lm. This is replaced by Kronecker delta. Then write down the rest of the things equal to 0. If we replace L by m, if L equal to m, that is a Kronecker delta nature. This is 1 if L equal to m. This is equal to 0 if L not equal to m. If you put L equal to m, this is 1. A bar mu nu xj x bar nu. Write down all the quantities here. Instead of L, this should be replaced by m. See here, Pjk m equal to 0. Because if you put L equal to m, this Kronecker delta equal to 1. So we can get the equation of this form. Since the quantity BMJK is an arbitrary tensor, we can arrange that only one of its component is non-zero. Therefore, the expression in bracket is identically zero. Say the previous case, in this equation, final equation, this tensor, so this is not equal to 0. BJKM not equal to 0. Therefore, the quantity inside the square bracket should equal 0. The expression in bracket is identically 0. Now write down the quantity and equal to 0. Again on inner multiplication with dou x bar lambda divided by dou xj, dou x bar r divided by dou xk. See here the dou xj term is present, dou xk is present. One quantity is expressed in terms of dou xj and another one is expressed in terms of dou xk. We have to introduce two indices, lambda and r, newly. Then multiply each and every terms by this quantity. Dou x bar lambda divided by dou x superscript j, then dou x superscript r divided by dou x superscript k into this. Then write down this actually. Minus of, once again, multiply these two quantities. Dou x divided by dou x bar mu into this quantity. Dou x bar lambda, dou xj, dou x bar r, dou x k into aijk equal to 0. Now we have to regrouping, which means that, see, this is in terms of x power j, this is in terms of x power j. Write down these two terms. And this is in terms of k, this is in terms of k. So align these two terms. Minus of, write down the terms as such, a equal to 0. Now we can replace them with the help of delta. Delta, see that these two get cancelled. Del of new lambda, same logic. Del of new lambda, then these two del of new lambda, these two del of sigma r into this quantity equal to, write down this as such. Bring this minus quantity to the right hand side, then this is changed as equal to this quantity. Now in the above, if you want to make this Kronecker delta equal to 1, nu equal to lambda. If nu equal to lambda, del of nu lambda equal to 1. If sigma equal to r, del of sigma r equal to 1. Then replace r sigma by r, here nu by lambda. Say nu by lambda, and this quantity sigma by r. See here, replace nu by lambda and sigma by r. Sigma nu lambda equal to sigma lambda lambda equal to 1, and delta of sigma r equal to delta r equal to 1. A bar mu. If you replace nu by lambda, this quantity is 1. Say instead of this nu, we have given lambda here. instead of this nu. Then instead of this sigma, we have to give r. Sigma is replaced by r, then only this quantity is 1. Then dou xi, write down the things as such. See here, lambda, dou xi lambda, dou xr. You have written all the things as such. Aij k. See this equation. This equation represents the transformation law for the entity Aijk. This is the transformation. Therefore, Aijk is a tensor because we have expressed the quantity Aijk in terms of a transformation equation. Now, this is dou x superscript I divided by dou x bar mu. So, I term is present in A. I term is present as a contravariant term. But see the quantities j and k. J and k not contravariant. Item is present as covariant because dou x superscript I divided by dou x bar mu. So it is a covariant term I. See the j and k, these two are in the contravariant form, j and k. Therefore, the transformation equation confirms that the given quantity A is a tensor with rank 3 and I is a covariant index, whereas J and K are contravariant indices. Now read of this. This equation represents the transformation law for the entity A of Ijk. Therefore, Aijk is a tensor. It is a mixed tensor with I covariant index. I is a covariant index and J, K contravariant indices. We may express A in this form. Therefore, we have confirmed that the given quantity is a tensor. That's all about the quotient rule.